Now, this time we want to look at some other equations and a little bit harder. But what we've got to do is really consider, again, keeping a balance of our equations. So with this time, if we've got powers or roots in our equation, again, basically what we're looking at here is what can we do to keep that balance? And we go back to the idea that we learned in the junior school of reversing our operations. So the idea here is the square root of 2t plus 1 is equal to 9. So what would happen, we took t, multiplied it by 2, added 1 to it, and then took the square root of it, and it's equal to 9. So we're going to reverse the operation. So how do we reverse that? Well, the last thing that was done was we took the square root. So to get rid of a square root, the opposite operation is to square it. So we have square of a square root means it goes. And then we square both sides, but that'd be equal to 81. And then we subtract 1 off both sides because that was the second last thing that was done to it. And the first thing was done was we multiplied by 2, so we divide by 2 to give 40. Again, check that it goes in. Another way to look at it is to say, well, the square root of what number would equal 9? So the square root of 81 is equal to 9. So what's under the square root sign must be equal to 81. So we can look at it in that terms. That's not a bad way to look at it. So 2t plus 1 would have to be equal to 81 because 81, square root of 81 is equal to 9. So what number plus 1 is equal to 81? Well, 2t would have to equal 80. Okay? And then 2 times what number gives us 80, and then so t would have to be equal to 40 because that's what number multiplies by 2 to give you 80. So you can look at it that way. This is a bit of a logic way to think about it. So again, find a number for p such that 3p squared would equal 48. Well, 3 times what number equals 48? Well, 3 slots of 16 would equal 48. So whatever we're going to put in for p squared would have to equal 16. Now, if p squared is equal to 16, what number could multiply by itself to give you 16? So we take the square root, but notice we're taking the positive and negative square root because minus 4 times minus 4 would equal 16, as well as 4 times 4 equals 16. So there's two solutions to this equation, as we said before. That's okay. You're allowed to have two solutions. Sometimes when it's a number squared, you're going to have two solutions. It's possible to have two solutions. You'll see later on that it's possible to have one solution or no solutions for something like that. But this works out okay for us. So that's what we like to do with these types of equations. Like again, you're reversing that, so you're seeing what the situation, what must the numbers be equal to. 3 times what gives you 48 is 16. What squared gives you 16? Plus or minus 4. So again, we look at this one. The cube root of a certain number is equal to 2. So cube root of 8 is equal to 2. So the 5x minus 7 would have to equal 8. So I've done it formally by cubing both sides, but you can do it informally by saying, well, 5x minus 7 would have to equal 8. Then 5x, what minus 7 would equal 8? Well, 15 minus 7 equals 8. So the 5x must be equal to the 15 there. So we have that, and then 5 times what number gives you 15? 5 3s are 15. So that works out nicely for us. In this one, we've got to do a bit of work. X cubed is equal to 10 squared plus 5 squared. Not much work because that adds to give us 125. And then the cube root of 125. What number multiplies by itself 3 times to give us 125? And that would be 5. You can throw that in the calculator. That's not a problem. That will do it for you. So we can see how we're reversing our operations and trying to think logically about it. Sometimes we're going to get a number of substitutions in this, of course. So we're going to get equations that result from that and then have to solve. So if I'm talking about v is equal to pi r squared h, keep in mind pi is not an unknown. Pi is not a variable. Pi is a number. Pi is a constant. So don't ever try and treat pi as a variable. It's not like r or h or v that can change in this one. Pi is always 3.14 and so on. So if you can quote many decimal places, good work. But that's what it's about. So we can't ever treat it other than just a number like 3, 2, 5, 7. That's what we got to do. So if we want to find one of the other three remaining, the three unknowns, we need 2 out of the 3 to give us an equation we can solve. This time we want to find the radius of a cylinder. So we want to find r, given that volume is 1000 and the height's 24. So if we've got that situation, we substitute our values in. We get 1000 is equal to pi times r squared times 24. So what do? Well, that's pi, that's times r squared. So we divide by 24, we divide by pi on both sides, because that would cancel it on this side and does the division there. And then you could either get that as a number, or you can leave it as I've done it, and then say, well, what number squared would give you 1000 on 24 pi? So take the square root, and it's approximately equal to 3.6, because it said 0.1. Now we're only getting an approximation, especially saying we're taking the square root, but especially because we've got pi. That's always going to give us we're only ever going to get an approximation. If we wanted to write it exactly, we'd leave it like that. And that would be okay, but the question asks us to find it as an approximation to 0.1. So other types of equations we want to look at, and this one is what we call an exponential equation. So notice in this one, we've got our powers as our unknowns. So that always adds a little bit of difficulty. Now we want to deal with these ones in the course in a much bigger way. And when we do, we use what we call logarithms to solve these a lot of times. We can do it by a bit of a guess and check type method here, though. When the powers and the values are nice, and our bases obviously. So we've got 2 to the power of x is equal to 8 to the power of 1 minus x. Now we're using a bit of our index laws as well, and the idea that we know that 8 is equal to 2 to the power of 3. So if that's the case, we can use our index laws to say 2 to the power of 3, 1 minus x would give us 2 to the power of 3 minus 3x. We multiply our powers out. Need to remember your index laws to do this one. Now if that's the case, because we've got the base the same in each of those, well, 2 to the power of a number would be equal to 2 to the power of that of the same number. So it means x there must be the same as 3 minus 3x. So we can set up an equation. Notice the bases are gone. We've just got it in a nice equation that we can solve as we've done before. We'd factorize, we'd add the 3x on both sides, and 4x is equal to 3, so x would be 3/4. So only works when x is 2 to the power of 3/4 is equal to 8 to the power of 1 minus 3/4. That would give us the same answer. So again, with 27 power of x, 81 x plus 1, so 27 to the power of x gives us 3 cubed. Notice I'm breaking it down to nice powers that are exactly the same. And that's what we're trying to do. So 3 to the power of x, 81 is 3 to the power of 4. If I couldn't get the same base, if that was, say, 102, I can't get the same base. I'd have to use logarithms. So don't worry about it. Any questions you come up with an exponent problem, an index or exponential equations at the moment are going to have nice bases for you to work with, so, or numbers that will convert to nice bases. So look for it to convert to a 2, a 3, a 4 maybe, or a 5. They won't probably get too much higher than that. So 3 cubed to the power of x gives us 3 to the power of 3x. 3 to the power of 4 with x plus 1 outside. Again, multiply those powers because that's what our index law does for us. 3 to the power of 4x plus 4 gives us 3x equals 4x plus 4. Subtract the 4x on both sides gives us minus x is equal to 4, or x is equal to minus 4. Got to remember, rewrite it to get the same base. This one's not too much of a problem, but we can solve it this way in this case. Is that, how do I reverse x to the power of 2/3? We put it to the power of 3 on 2. So we put one side to the power of 3 on 2. We put the other side to the power of 3 on 2. So we get 9 to the power of 3 on 2. Throw it in your calculator, but again, you would know that that would be the square root of 9 cubed. So you could write it like that, or I'd probably look at it as square root of 9 all cubed, because the 3 is cubing it and the 2 is taking the square root of it, which would be 3 cubed, gives us the 27. So that's how we'd be able to do it. I've just done it without a calculator. You could throw it into the calculator and that wouldn't be a problem. Okay, so that's what we need to look to do with exponential equations. We're reversing powers if we can. If we can't, when the powers are powers are unknown, we need to get that same base to work with that at the present time. Later on, we'll do some logarithms and we can solve them in a different way and we can solve with different numbers that necessarily the bases aren't going to work out very nicely for us.